Hello, students, and welcome back to eCoreAcademy. My name is Anita Raj. I'm one of the co-founders here, along with my younger brother, AJ Raj. Today, we're going to be continuing our Algebra 2 course with a lesson on rational expressions. Our objective for today's lesson is to learn to multiply, divide, and simplify rational expressions. We'll talk about exactly what rational expressions are, what techniques we can use to do these operations, and then go over a few examples together. Before I get into the video, please make sure to like, subscribe, comment, hit the post notification bell, and share using our socials. All right, so in our introduction, let's discuss exactly what a rational expression is. What should you be looking out for to qualify as a rational expression? So a rational expression is the quotient of two polynomials. Remember, a polynomial is just a series of terms separated by addition or subtraction. These terms will have some variable like x in them. That variable can be raised to a power, and that variable can also have a coefficient. We usually organize polynomials in order of highest degree, meaning highest, that term with the highest exponent, to the term with the lowest exponent. So in this case, it's one polynomial over another polynomial. You'll have one in the numerator and one in the denominator. To have a rational expression in simplest form, which is what we are going for, which is always our goal, to have things in simplest form, we want the numerator and denominator to be polynomials that have nothing in common. So what does this mean, nothing in common? Well, it means that they don't have a factor, a common factor, meaning if we factored both of those polynomials out, we should make sure that all common factors have canceled and that we have this most simplified answer. So in simple words, we're trying to eliminate all common factors to have the simplest form or reduced form at the end of whatever operation we're trying to do with rational expressions. While we're doing these operations, I want you to keep in mind some restrictions on the variables. So you often need to prevent division by zero in the original expression. What exactly does this mean? Well, if we have the original expression, which is just a polynomial in regular form with terms separated by plus or minus signs, from highest degree to lowest degree, whatever that might be, and then we go to factor the two polynomials in the rational expression to simplify it. When we look at our factors, we can't have a factor that's common in the numerator and denominator. That we have to consider those, because if it's found in the denominator, we have to make sure that, remember, these are variables. X can be equal to anything. So if we have a common factor in the denominator, for example, if we have x minus 3 as a common factor between the numerator and denominator, we have to make sure x never equals a number that makes the denominator 0. So in this case, x cannot equal 3, because if we plug 3 in, 3 minus 3 would be 0, and then that part of the denominator is 0. If you multiply it by anything else in the denominator, it's going to be 0. You're going to run into the problem where you have a number in the numerator polynomial over 0. So because we don't want that number over 0, we have to make sure that when we factor, we look at restrictions on variables, we list them out so that if we return to the original expression, it still works in regards to the fact that we don't have numbers that cause zeros in the denominator. So moving on, we're going to look at our first example. We're going to simplify rational expressions. And when we do, remember, like I said, we're going to state any restrictions on variables. So here we have the rational expression 24x cubed times y squared, that's the numerator, over negative 6x squared times y cubed. So what we're going to do, as I showed here, I circled different sections of these two polynomials so you can focus on common, well, in this case, variables. Here we have two integers, so we can work with them pretty easily. Here we have x's, so we can work with those easily, and here we have y's, which we can work with easily. Why I did this is because it's pointless to, try to compare y squared to an x squared in regards to division. You're not going to get anywhere. And this is just to break it up, because for some people looking at this, they might be immediately able to get the answer, but for others, maybe breaking it up will be easier for you to find simplest form. So again, we're trying to simplify this rational expression. If we look at the integers first, 24 divided by negative 6 is negative 4. If we look at the x's, x cubed divided by x squared. Well, we're doing division of exponents, so we can technically just subtract the exponents. 3 minus 2 is 1, so we're going to get x to the power of 1 in the numerator. Now we have y squared divided by y cubed. Be careful here because the larger power of y is in the denominator. So if we do the math here, we get 2 minus 3 because we're dividing. So subtraction of exponents, 2 minus 3, we get -1. So we could write the answer as -4 times x times y to the -1, or to put it in whatever's proper form. Remember, y to the -1 is the same as 1 over y. So we just put y in the denominator. When we do this, we look at the denominator and see we have two unknowns here, two variables. So what we do is we set each of these equal to 0. So x squared equal to 0. If you solve for x, square root both sides, square root of 0 is 0, x equals 0. In this case, x cannot be equal to 0 because if x is equal to 0, it'll make the whole denominator 0, and we don't want the denominator to be 0. If we look at y, and we set y cubed equal to 0, the cube root of 0 is also 0 because we're trying to solve for y, and then we get y is equal to 0, but in this case y cannot equal 0, or again the denominator will be 0, and we don't want that. So this is what it means by stating restrictions on variables. What numbers can the variables not be, so that in the original expression we don't run into a situation where we have the numerator equaling some number and that is over 0. Okay, so let's move on to example number 2. We're going to simplify the following rational expression. We also want to state any restrictions on variables. And here we're actually given a more complicated looking polynomial. At the top, we have 2x squared minus 3x minus 2 over x squared minus 5x plus 6. As you can see, these are not separated by a multiplication sign, so we're going to have to actually factor these. We can't do what we did in the last problem. If we factor and remember, we're trying to factor to see if we have any common factors so that we can simplify this whole rational expression. So if we're trying to factor the top, we can see that we can use the guess and check method. So we can put 2x and x in two separate parentheses because the only factors of 2 are 2 and 1. Now we're trying to figure out what numbers we're going to be putting in these parentheses with them. And to do that, we look at this -2 on the end, and we look at the factors of -2. Lucky for us, the only factors of -2 are going to be 1 and 2, and then one of those is going to have a negative sign in front of it. So you can try those out and see how they fit. You can plug in -2 over here, plus 1 over here. You can plug in -1, -2. You just plug them in until you figure out something that works, and hopefully you can do it in your head. And for us, 2x plus 1, the plus 1 in the first set of parentheses, and then a -2 in the second set, bring us back to the polynomial in the numerator. If you look at the denominator, x squared minus 5x plus 6, we apply the same rule. Lucky for us, the coefficient of x squared is 1, and 1's only factors are 1 and 1. So we have an x and an x and another x in the parentheses, and then we look at plus 6. Plus 6, its factors are 2 and 3. We have to figure out, are those both going to be positive, are those both going to be negative, and which one goes in which parentheses. In this case, it doesn't really matter because we have x's in both. It's not really it's not different like 2x versus x. So you plug those in, you try, you see -2 and -3 work to get you the -5. And then you see if there are common factors. In this case, x minus 2 is a common factor. So you can see I crossed that out, and that crossing out helps you simplify that there's only a 2x plus 1 left in the numerator and then x minus 3 left in the denominator. And that will give you your simplified rational expression. If we're trying to look at restrictions on variables, we're going to focus on the denominator again. In this case, we're going to set this whole expression x minus 2 equal to 0 and solve for x. So x would be equal to 2. In this case, we want to say x cannot be equal to 2 because if x is equal to 2 here, if we plug 2 in, that's 2 minus 2 is 0. 0 times x minus 3 is equal to 0. Then we have a problem where we have some number in the numerator over 0, which we can't have. And the same will occur if you plug 0 into this polynomial here in the original expression. So we cannot have x equal to 2. We can do the same with x minus 3. So x minus 3, we set that equal to 0. We see that x cannot be equal to 3 because if it's equal to 3, we get a 0 in the denominator again. Even though x minus 3 doesn't have a common factor, because it's in the denominator, you also have to check it. So those are the two restrictions on the variable. X cannot be equal to 2 and x cannot be equal to 3. And here, for our last example, we're going to be multiplying and dividing rational expressions. So in the previous two examples, we were going over how do we, simplify rational expressions. Now we're actually going to be doing an operation. In this specific problem, division. We're going to multiply and divide the following expressions and simplify them completely. So we have to divide, but we also have to make sure it's in simplest form. We also have to state any restrictions on the variables. So here are the two expressions. 2 minus x over x squared plus 2x plus 1 divided by x squared plus 3x minus 10 over x squared minus 1. So the very first thing I did was I rewrote these and by factoring them. So first I look at the numerator here, 2 minus x. I want the variable first, so I rewrote this as negative x plus 2, and then I factored the negative sign out. I put that in front and turn this to negative times the quantity x plus 2, or negative 1 times the quantity x plus 2, just because it'll be easier for me to look at the other factors that I come up with and cross it out, see if there's any common factors. So I rewrote it in this form. Then if you look at the denominator here, x squared plus 2x plus 1, you can factor this into x plus 1 times x plus 1. This is a perfect square trinomial. You would just look at the factors of 1, which are 1 and 1, and that's pretty straightforward. You have to determine whether they're positive or negative. Because it's a positive 2, we make them positive. It's just pretty easy to factor. Then we come up here to x squared plus 3x minus 10. We factor this as well. The factors of negative 10 are 1 and 10, or 2 and 5. In this case, 2 and 5 worked. Positive 5, negative 2 brings us to negative 3 if we multiply this all out. So our factors here are x plus 5 times x minus 2. And again, I'm hoping that you can do all this factoring work by yourself. Make sure to check out videos in the quadratic section where I go over the whole guess and check method very thoroughly, if you feel a little bit iffy on that. And lastly, we have x squared minus 1. This is just a difference of squares. And we factor that with x plus 1 times x minus 1. So this should all be pretty straightforward. The factoring should be pretty straightforward. I rewrote all of the factors here, I believe. Yes, so I rewrote these polynomials in the forms of their factors. So I wrote negative 1 times x minus 2 instead of 2 minus x here. I wrote these two factors in the denominator. Then I changed this to a multiplication sign, because remember, these are actually fractions just with polynomials instead of integers in the numerator and denominator. So because we're doing division, we can actually do multiplication by the reciprocal. So I can actually put the denominator in the numerator and the numerator in the denominator and do multiplication instead. You can multiply by the reciprocal. So I wrote these two factors of x squared minus 1 in the numerator up here, and then these factors of this polynomial in the numerator that now in the denominator, and this is much easier to work with, so I can see what the common factors are. Here, I see. So what happens is you can think of this quantity in the numerator and this quantity in the numerator as one big numerator. You can think of these quantities in the denominator as one big denominator because of this multiplication sign. Think of the multiplication sign as just merging these two fractions together. So this whole thing is our new denominator, this whole thing is our new numerator. So anything in the denominator can cancel with anything in the numerator and vice versa. So this x minus 2 we have in the numerator. Let's look to the denominators of both of these fractions to see if we have an x minus 2. And luckily for us, we do over here. So I cross both of those out. Then I'll move over to this x plus 1, and let's look through our denominator, see if we have anything that matches. We have an x plus 1 over here, so I cross that out as well. And then nothing else will match. And because nothing else matches, we pull these over, and this becomes our simplified fraction. So you cannot forget this negative sign in front of the x minus 2. It doesn't just go away. So make sure you bring that over. I have this x minus 1, so I just distributed the negative sign. So it becomes negative x times negative 1 times negative 1, which is just plus 1. And then I can just leave these as x plus 1 times x plus 5, and then I actually ended up multiplying them out, and you get x squared plus 6x plus 5 in your denominator. So this is how you would give your simplified quotient. So not only did you simplify the rational expression, but you actually did an operation, which was division. But don't forget to state any restrictions on the variables. And what we're going to do is we're going to go back to when we first completely factored out with the numerator and denominator. We're going to look at our denominators, and here we have x plus 1 and x plus 1. So we're going to set x plus 1 equal to 0, and we see x cannot be equal to negative 1, or else the denominator will be equal to 0. We look over here. We have another x plus 1, so we can ignore that because we already said x can't equal negative 1. But we have an x minus 1, so let's set that equal to 0. We solve for x, we get x equals 1. Well, x cannot equal 1, or again, the denominator will be equal to 0, which we don't want. It'll be some number over 0, which is again is a big no-no. So that's it for the problem, and that's actually we actually have one more example that I'll go through very quickly. Example number 4. Sorry that I wrote example number 3 up here, but let's go through this. And I wanted to work through this because this is a bit different, but we're going to be doing division again. So we have a squared plus 2a minus 15 over a squared minus 9 divided by a plus 1 over 3a minus 12. So first I factored this numerator, which came out to be a plus 5 times a minus 3, factored this denominator, which is a difference of squares, so I got a plus 3 times a minus 3. This numerator here is in simplest form, can't really factor any further. And then I simplified this denominator here because both of these terms had a common factor of 3. So I just pulled out the 3 and wrote this as 3 times the quantity a minus 4. So now that this is all written out, I took these factors and I rewrote them in place of the polynomial. So I took these factors in the numerator, wrote them here, took these factors of the denominator, wrote them here. I changed the division sign to a multiplication sign and wrote the reciprocal of this rational expression, where I just put the a plus 1 in the denominator and the 3 times a minus 4 in the numerator. So it's multiplication now. Then we're going to look for common factors. Let's look at a plus 5, and then let's look at the denominator. Remember, this is one big denominator, this is one big numerator. Because the multiplication sign is kind of merged, so a plus 5 has no common factor in the denominator. A minus 3 has a common factor in the denominator, so we cross that out. And then a minus 4 does not have a common factor in the denominator, so we also leave that out. So our final rational expression is going to be 3 times a minus 4 times this a plus 5 that was left out. And then the denominator will be a plus 3 times this a plus 1. And then if you multiply that all out, you get 3a squared plus 3a minus 60 over a squared plus 4a plus 3. What you also have to do is you have to make sure that you state all the restrictions on the variables. When you do that, make sure to check a plus 3, which comes out saying that a cannot be equal to 3, a minus 3, which comes out saying a cannot be equal to negative 3. In the previous one I said a cannot be equal to 3 for a minus 3. A minus 4, a cannot be equal to 4. And make sure to also check the a plus 1 over here, because we did put it in the denominator when we flip the rational expression. So a cannot be equal to negative 1 either. And that's it for the video. I hope you enjoyed. If you did, please make sure to like, subscribe, hit the post notification bell, comment down below, and share using our socials. Please look out for more videos on this topic of inverse variations, and I'll see you soon. Thank you.